It's great to meet and welcome you to AI Week Columbia, the space to dive into the latest trends in programming and the groundbreaking technologies developed by NVIDIA. This event is proudly brought to you by SoftServe, in partnership with Universidad de los Andes, Universidad EIA, and AWS. A true example of how teamwork makes extraordinary things happen. Together, we are shaping the future of Colombia's tech ecosystem by turning bold ideas and innovations, like me, into reality. And now, let's meet our speakers, but first, and once more, welcome to AI Week 2025. Thanks to all our keynote speakers. We believe technology empowers us to expand what's possible together, and today, Eric Liu will show us how. Let's start with building the world in real time, spatial digital twins for the infrastructure of the future. Have a great talk. See you soon.
Well, hello everyone. Hello, Eric. Welcome. We're so
Hello.
glad, so happy to having you here. Welcome everybody here in the talk. Um, we know that it's kind of late. We know that we have been working all day long, but anyway, we are here for this interesting talk. So today we have a very special guest, our close friend. Let me call you a friend, Eric, in this AI week. So Eric Liu, he's the founder and the CEO of TwinMatrix. Just to summarize, like what is about like Eric, I can say that he's the person who's bringing the future into the present right now. So Eric, you can introduce yourself. I think a little bit deeper and let them know a little bit more about you. One more time, thank you for joining us. Thank you for being here, and the stage is yours.
Perfect. Thank you so much, Juan. And thanks to everybody. And of course, definitely NVIDIA, AWS, and of course, University de los Andes. So I'm very excited to speak today. And I'm sorry I did not bring my AI companion to do this presentation this time, maybe next year. So I'm going to share my screen and let me know if this is coming through okay. It's
Yes,
okay?
it is. Yes, sir.
Perfect. Perfect. So today we're going to be talking about building the world in real time because the use of spatial digital twins for the infrastructure of the future. So one of the key things is that just to give a little background about myself. So I'm a serial entrepreneur and really worked with a lot of different industries over the years. I might look young, but I've actually been in the industry for 30 plus years and also 20 years in Silicon Valley. And before that, I was actually working with the creators of Diablo, if you heard of that game before. I grew up with it, but at the same time, then I realized, you know what, working with the legendary visionaries of the video game industry has really transformed the way that spaces interact. So I remember actually in university playing Diablo 1 and 2. And then after graduation, I decided to join them for the future of what they were creating. So at the same time, over the years, after I worked at NVIDIA, I was at NVIDIA for about 4 years. I helped build the video game industry connections with NVIDIA. Because as we know, NVIDIA came from GPUs, right? Even now, it's all GPUs. But at the same time, it was really focused on gaming. And gaming technologies has transformed the way that we can work as well. So these days, all of those different GeForce business units really propelled NVIDIA to where it is today, which is what over $4 trillion company. So the key of what TwinMatrix does is that it's the intersection between technology, human-centric design, and the built environment. So I like to say that because at the end of the day, we're all standing or sitting or laying down in a space. But the key thing is, how do you make it smarter? How do you actually interact with it and understand it? How do you make it into sort of a living, breathing organism? And really, the mission of TwinMatrix is to transform and optimize these environments through spatial artificial intelligence. And I'll explain exactly what that means. And to foster collaboration, because at the end of the day, it's still humans who rule the world, right? We need to interact with each other no matter where you are in the world, whether you're at Colombia or whether right now I'm actually in Singapore. So we're very excited to actually talk about this because everything starts with vision. We as human beings actually get information through our brains. Actually, 90% of it is visual. Just like right now, you're looking at this presentation and understanding what is being processed. It's visual. So when we talk about human-computer spatial interactions, so I'll be talking a lot about spatial technologies today. It's really about how do we understand that, right, as human beings? Because we have the physical world, everybody's in your own room or classroom, and then there's a digital world, all the zeros and ones that are going through the walls that we do not see. We don't need to see because it's just too much data. But at the end of the day, what about the spatial interactive layers? What about the most important things that needs to be alerted? So this is the key thing about human-computer spatial interactions. We should respond to basically the alerts that AI tells us. And really, that's a lot of these key information today that I'll be talking about really leads up to that and how we're actually implementing it in the infrastructure of today. For example, with airports, with critical infrastructure, and other places. So quickly, we can look at the evolution of the desk and work. So, I grew up in the 80s where we had a lot of these things on our desk, especially fax machines, if people understand that. But over the years of digitalization, everything has transformed and into our laptops. And over time, it really progressed past the laptops into basically the palm of our hands. And I think really this is really critical to think about, right? It's always good to look back in history and see where information has come to. And now these days, everything's the palm of our hands. We could actually access the entire world's internet in the palm of our hands. And very soon, it's going to be actually on our faces as well. So when we look at technology that's changed the world, right, then and now, this is actually over 10 years ago, but even now, and probably the next 10 years, instead of actually holding up iPads during concerts, you'll be actually recording everything on your face. So this is the power of technologies that are actually coming together. And when we talk about human revolutions, it's all about the connectivity. The connectivity is really critical to the global infrastructure because as evolutions have happened over the years and as things are becoming more information and data-based, it's really about the connection of human beings. Because I always want to bring it back to that. It's always about the human beings. And when we talk about industrial revolutions, we're looking at Industry 4.0. A lot of people have been talking about 5.0, but we're not there yet. Because when we talk about ID 4.0, it's about cyber-physical systems, which essentially is a digital twin, if you think about it. IoT, right, when you have basically dumb sensors becoming smart sensors by just adding either a Bluetooth chip or a Wi-Fi chip, or these days maybe a UWB chip. And the networks are really important, connectivity, 5G, 6G. And of course, when we talk about AI, we don't even have to even look at this anymore because it has far and surpassed every single week, every single month where AI is heading. And this is the power of research of AI. And it's over here when the human baseline has been surpassed about 2 years ago. And now we're looking at ChatGPT 5, we're looking at Google Gemini, basically 3.0 is coming out soon. And now what's the next step? What is physical AI? How do you actually embody artificial intelligence inside the physical world? So all of this is actually coming together into the real world now. So this is why digital twins is really critical to a lot of the operations of the world. Because when you have a physical factory, or it could be a space, or it could be an airport, and you completely digitize it to understand what's going on inside of every single sensor, that's how you can use AI to optimize as well. And when we look at smart cities, right, it starts with mapping. And that's really the key thing that TwinMatrix focuses on. So let me show you a quick video of what we did previously in Shanghai, because I was in Shanghai for about 8 years building digital twin companies. And you can see here, actually, China has very, very focused on quickly using innovation to empower different data silos, to connect different data silos. So this is actually a very dystopian type of video, but you can see where the technology has led. So this is actually all of Shanghai. So we actually had a drone company go and fly it to capture the physical world onto a 3D technology, just like a video game. Except this is not 100% virtual. This is bringing the real world into the palm of our hands to understand and to access all the information. Because at the end of the day, every single data silo is not interoperable because it's completely segregated. And what we were doing is to actually bring the spatial understanding of buildings, of roads, of traffic patterns into the system. And of course, visualization, like I mentioned earlier, is very critical because once you actually see this in 3 dimensions, you can actually go anywhere. You can be teleported anywhere, whether it's VR or not. But this was actually for the police department. So as we know in China, a lot of the data is really, there's not a lot of privacy, let's just say. And the key thing about this type of technology is that once you capture the physical world, what else can you do with it? How do you make it come alive? And once you capture, just like, for example, you take a photo or a 360-degree photo of an area, that's a capture in time. That's not a true digital twin. A true digital twin should be interactive and should be real time. And real time meaning that you can actually access all of the IoT and the sensors, whether it's CCTV, whether it's traffic flow, whether it's any type of information. This brings the power of a true digital twin to life. So it's no longer just a static image. So when we were working with the police department there for the Huangpu district, so if you ever been to Shanghai, one of the most populated areas is actually the Bund, very, very famous place. But what they wanted to do was actually to bring in real-time footage and to just like a video game, and this is very, very sci-fi as well, you click on the cars that are streamed live onto the platform to understand the license, to understand where they were. And also, of course, in China, they want to actually track more Big Brother's watching type of thing. So you can see how a lot of these smart city digital twins has been evolving based off of the data availability. And that's one example. I'll show you other examples that we've done. So with Singapore, I worked with National University of Singapore to spatialize the first net zero building in all of Southeast Asia. And again, this is not just to understand, but to control the physical world. So I want to pause right here. It's very critical to understand this because I was actually in the US and I was able to log into the AWS GPU cluster and I was able to actually move this disinfecting robot during COVID days. And of course, you have to double check that in the real world to see if it actually moved using CCTVs. And once that actually did move, I was able to turn it on to disinfect. And this was halfway around the world. But I didn't realize then that there was a PhD student sitting right there in the chair. And of course, that person freaked out and ran out the room because the robot came to life. But you can see how powerful this is because these days, NVIDIA is pushing Omniverse, pushing physical AI. How do you embody AI into the physical world through the use of robotics? And this is really truly next generation, and it will actually penetrate every facet of our lives. So this is not just research anymore. It's really being developed now. This is why our partnerships with not only AWS, but also NVIDIA and universities like you is really critical to how to scale. So other use cases, for example, as I actually fast forward through a lot of the key digital twins that we've done, we've actually started doing spatial intelligence, tapping into CCTVs to understand user falls, to understand basically data of where people are dwelling, what are they touching, what are they buying. And this is helping retailers like Balenciaga, and recently we're working with Tapestry, which owns Coach and Kate Spade, to understand the intelligence, because this is generating data. Each time you go somewhere, right, it's capturing this information. But how do you make sense of it? How do we as human beings make sense of all of this? So another example over here, this is the water treatment site. So critical infrastructure. So we're managing multiple water treatment sites in Singapore. And this is from a safety and security perspective. So I'm going to pause at basically right around here. And you can see that they're using this technology, this platform, to understand various different water treatment sites around Singapore, because it's just so much easier, right? It doesn't make sense for them to access the CCTV IP addresses, which is hundreds, right? If you think about in Shanghai, when we actually did that project, we integrated over 300,000 CCTVs across Shanghai. And of course, if you put that into a spreadsheet and IP addresses, how do you understand where it is and what you can do with it? This is why these spatial digital twins are super important. And so this is the power of spatial digital twins. It's not only for monitoring and reporting, but it's also to keep people safe and for access control. So they're able to use our system to allow the contractors in and out of remote sites, which makes it everything centralized. And that's really where a lot of these different data silos are starting to connect to. And what's even better is that this actually empowered people to save lives, because they started wearing, the contractors started wearing these sort of like Apple Watch where it can detect a fall, but it also has a GPS and an SOS button. So if something happens, they just tap it, and immediately the security guard who's monitoring the digital twin can click on the closest CCTV and zoom down as if it's live street view. So we all know about Google Street View, but they can actually jump from one CCTV to the other to double check that they're okay, or they can send help to basically, figure out what's the problem. So this is the power of why we are pushing a lot of these spatial digital twins, because at the end of the day, it's really helping people and also saving lives. So this is why we believe the future of spaces is increasingly connected. And we built something called SpatialVerse, where it focuses primarily on the map itself. Because at the end of the day, like I said, if you just take a snapshot, or if you don't update the map, whether it's 2D or 3D, of the exact digital replica of the physical world, and let's say something changes in the physical world, if the map is not updated, then nothing else on top of the layers can be unlocked. Or if it is unlocked, then it just becomes a useless visualization. And this is why operation efficiency is really critical, especially in Singapore. And that's why I'm actually located in Singapore now. So a lot of the key things is that a digital twin, it connects a lot of the data together and to basically break down the data silos and to offer collaboration and interoperability. But the true power comes when you actually inject AI, right? Because AI is a tool. AI needs to be focused. And this is something where I'm going to showcase a lot of the key things that we're doing now. So over here, when it comes to digital twins and Singapore's Changi Airport, so Singapore has the airport, only one airport, the main airport, but it's actually a top airport in the world. They keep winning multiple awards. I think this year they also won #1 as well. So we're up to over 40 different departments now on top of our system. It's not just basically mapping. So over here, you can actually go on to changiairport.com and access our digital twin, but it's an anonymous view. So this is completely running on AWS cloud, and we're getting about 42 million hits per month right now. So this is actually all of the queries on our maps. Oops, let me fast forward. And it's not just the number of hits worldwide, but it's also the beginnings of a true digital twin for the entire airport and all of their departments. Because what you can see online is only the very, very first layer. But what we can actually empower them is actually a complete content management system of the entire airport, from not only the terminals, not only the shopping areas, but also the entire airside. So there's a lot of different use cases that are happening and popping up with the use of this technology. And the power of this, again, right, just like over here, very easy tool to maintain the digital twin is really what we focus on. So there's over 600 tenants. So that means it could be, food and beverage, restaurants over here, or it could be shopping. But these guys change every single day, right? New tenants come in. Maybe Nike will be replaced by Adidas. But how do you maintain that map? And that's why we give them a lot easier to use tools. But the key thing here is that as soon as it's actually maintained and updated, because there's so many robots inside of Changi Airport, whether it's for safety, security, or cleaning, they read directly live from this platform and they go around the new perimeter. And that is why the key power of a digital twin is that the maps must be maintained by the respective owners. And of course, what we're actually starting to do is not only wayfind and navigate people. So let's say all of a sudden somebody wants to walk around this path and go to the restroom or the bathroom. As they're actually walking, we can actually serve them augmented reality advertising. Of course, they have to opt in for this. But these are the things that we're starting to experiment, because the airport, as we know, with all of these tenants, as you're walking by these booths, you don't know what's actually happening unless you actually can visualize. And this is where the spatial computing comes in. And I'll talk about that very soon. And of course, accessing any type of data silo, whether it's IoT or whether it's something else. So this is where we're starting to scale into 40 plus departments. We're on board to scale into additional 50 by the end of Q1 of next year. And the robots and physical AI is really critical to the power of the next generation. So I'll show you a little bit about what we call airport management platforms. So at a glance, you can actually spatialize and understand everything, all the data silos that's going around this space, whether it's asset management for live tracking of planes or vehicles, or if it's optimization, right? And this is where a lot of the omniverse use cases I'll talk about in a second, because you have what we call brownfield and greenfield, right? Brownfield means that it's already, the building exists. There's already a lot of things existing, and we actually bridge those data silos. But greenfield means that it hasn't been built yet, or maybe it's being planned. So what's amazing about Changi Airport is that there's 4 terminals that are already built, and they're in construction for the Terminal 5 right now. And with Terminal 5, so I'll show you a little bit about basically why, like how we can utilize this because of the wayfinding element. So let's say you land in Changi Airport and you want to go to the Singapore Flyer, which is actually the Ferris wheel. So we have already connected all of these different areas together. So you land at, let's say, gate F31, and you can basically navigate. So this is wayfinding at its finest. But what about outside of the terminals? And then what about once you reach there? What if you're an engineer that needs to actually understand what's going on with the Singapore Flyer? And this is the power of full connectivity across an entire country. Singapore is a small country, but at the same time, it's very advanced in innovation and also connectivity. So let's say once you actually arrive over here, you want to be able to access the data. And let's say they give you permission to access the energy distribution DB boxes. And this is where Singapore Flyer is actually with certain IoTs running on our platform, where we actually spatialize exactly the data distribution boxes and all of the sensors connected via temperature and humidity. So previously, before they actually started spatializing on our platform, they were going around with security guards measuring all of the temperature and humidity every single 30 minutes. But now they just actually get alerts directly from our platform. So again, over here, when I mentioned there's multiple terminals, 4 terminals in the shopping center, Jewel, and of course, the entire airside. But what they're building right over here is Terminal 5, but they're breaking it down to 5A, B, and C, because it will double the entire capacity of the airport. But now, what about how do you actually know how to spread things out, right? How do you know the traffic patterns? This is where the simulation comes in, because there's so much historical data of planes landing, of baggage handlers, of all of these things that Terminals 1 to 4 has over the last 10, 20, 30 years, if not more. But now what about Greenfield? So this is where Omniverse comes in. So I love Omniverse is because, well, first of all, I worked with, so I know very well the Omniverse team. So Rev is actually a good buddy of mine. So he's in charge of the entire NVIDIA Omniverse as well as Cosmos. And the key thing about Omniverse is that if we actually already have a 3D model of the existing and also future terminals, we can actually start understanding how to optimize cleaning robots, where they're supposed to be, what they're supposed to be doing. How do you actually spread them out? Because the key question now is that, well, if we're going to double capacity of the entire airport, how many more robots do they have to purchase, right? And where do they belong? Where should they be charging? Where are the charging stations? So a lot of questions. But the key thing is it starts with the digital world, right? It starts with basically having the BIM model or some type of map of the airport. And then you, of course, empower the intelligence of these robots. So the key thing here is that going back here is that as soon as this opens, they'll know exactly where to place the robots, how many to optimize the cleaning and the security patrols of terminals 5A, B, and C, and also how do you spread out the people, because then they can actually hire less people, but spread them out so that the robots take over and help with a lot of the tasks and chores. So this is the power of Omniverse, and I'm going to talk a little bit more about that in a second. Because when it comes to Omniverse, right, fusing AI with digital twins, like I said, AI is a great tool, but it needs to be finely tuned and focused for specific use cases. Sure, we have generalized world AI, right, when it comes to chatbots, but how do you actually get things done? How does it know all the data and it can actually give alerts to the operator so that they can actually do a better job? So it's essentially, I see it as more of a superpower, right? If you if you're into Marvel, because I'm always about how do we augment our own capabilities. So, for example, the spatial intelligence of this entire warehouse, where the people are, and also where the robots are, right? And if something changes in the physical world, so this is NVIDIA Metropolis, which is also a part of the video analytics tools that connects to Omniverse inside of this digital world. So it can know where people are. It can optimize the way it's supposed to tell the robots where to go. Let me go back here. And basically, it'll also automatically know if something has changed in the physical world. So for example, if something like this happens, then automatically the robots has that spatial intelligence and it can actually navigate to a different path that's more optimized versus just sitting there and waiting for it to be cleared, which is right now a lot of the robots are doing. So this is why digital twins, as well as mapping, and then of course, integration of AI can help and empower, give you superpowers essentially. So for example, the operator can ask it, hey, anything happen? Something peculiar happen? Yes, here's exactly what it is. So even if it's overnight, if something happens overnight, you wake up, you access the digital twin, and the AI can tell you everything that's important for your work. So when we talk about sort of how things are designed these days, right, whether it's a supercar or whether it's a massive building, a skyscraper, back in the day, of course, I'm starting to show my age, is the information age where we started with paper and pencil and highlighters and everything, and then we moved to software. Right. Back in the day, it was called Lotus 123. It was one of the first spreadsheets. So I actually used this growing up. And of course, as more and more data became generated with CSV files, like there's no way us as human beings can read 100,000 lines of data. And that's why data visualization tools came to be. And Excel is really powerful at that. But the key thing here now, like I mentioned, what's the next step? Right, the information age as we're actually progressing, they started using CAD, right, and then of course 3D CAD to design things. But the biggest problem with 3D CAD, with AutoCAD, is that let's say the glass and the wheel and the engine is just a mesh. It has no relationships whatsoever, no metadata. So now, of course, we look at sort of BIM information, so building information modeling. If you think about this, every single system, whether it's electricity, whether it's, let's say, the piping, all of this is just like our human bodies, right? We have the circulation system, the nervous system, and all of this has to work together in tandem to actually help improve things and help actually have a holistic view of what's happening. So we would like to always conjecture about when the intelligence age has happened or if it's already happened. And of course, we always love to talk about, AGI or artificial superintelligence. But at the end of the day, it's really right now throwing more compute at the problem, as people know. And this is why NVIDIA is basically at the core of the AI revolution. And it's very ironic because coming from gaming to physics to actually simulation and now AGI. So now I wanted to quickly talk about the spatial computing, because this is really critical because we as human beings, we're going to bring it back. we got to understand, what does it mean to actually interact with data? How do we interact with it in a more natural way? And this is basically a lot of the technologies that I've been working with over the years. So even back in 2017, right, I was working with Huawei in China, and it was really about, let's say you get to a new university or you get to a new place. How do you know the data? How do you access that? So I was working with them and trying to prove this out, is that to actually give you augmented superpowers as you look around, right? It can actually overlay any type, again, coming from gaming background, you can overlay all sorts of not only advertising, just information to get you from point A to point B faster. And this is the power of these technologies, is that the information, the zeros and ones that we don't see in the machine world, we can actually understand and interact with it. And this is where things are headed. And where I see it, of course, with even Pokemon Go, right? The most famous augmented reality game in the world. But that's just a game. But how do you actually bring that into every single space, whether it's outdoors through mapping or whether it's indoors? And this is where things are starting to connect very, very powerfully. So for example, if you have a meeting in J2 building, how do you actually go in there? How do you actually get introduced? And of course, we can talk about digital avatars and how do you actually talk to basically these avatars to lead you to where you need to be. So there's going to be a lot of these technologies that are releasing over many, many different types of vendors. And of course, back in 2017, you had to hold up a phone. But of course, when it comes to spatial computing, no longer you have to do that. I actually worked also on a, so if you watch Stranger Things, if you heard of that TV series on Netflix, we actually started working with these technologies back in 2017, where we can actually, if not to spoil it, but there's an upside down world in Stranger Things that reflects the real world. So we actually use a lot of computer vision understanding of the physical world to turn it into the intellectual property of Stranger Things. So we were actually working directly with Netflix, trying to prove this out for marketing. And back then, this looks very silly because it's still a phone you have to hold to access that. But of course, these days we can just wear glasses and it's coming. And this is something where we see a lot of, it's very silly because you're looking at such a small screen, it doesn't make sense. But as soon as we actually put things on our head, on our face, and the entire world changes to basically that information, that's when you start interacting very differently. So lots of use cases. So one of my friends and also ex-staff, back in 2019, this is how you actually interact, right? You had to actually hack together things, a massive battery, right? You actually had to have the understanding of where your hands are. So leap motion hand tracking and all of that. But of course, these days, right, spatial hardware has progressed. And of course, we all know about Apple Vision Pro, right? Still very heavy. I actually have a unit over here. So I have a unit over here, right? I don't use it as much because again, it's a little bit too heavy, let's just say. But of course, we all know that Apple will continue progressing it, making it lighter and more useful. But they're already starting to prepare for the spatial inevitability of these technologies. So whether that's understanding sports or understanding the data that you care about, that's really the critical thing. Or if it can empower people to perform their jobs better. And that's really the power of spatial technologies, right? Even humanizing spatial technologies. So for example, if you're in Colombia and I'm in Singapore and you're wearing a Vision Pro and I'm wearing one, I can actually see you. Right now, it's sort of a bobbing head walking around, but you can interact together, right? We can actually watch movies together. We can work on a whiteboard together. There's all sorts of things that we can do together to bridge the gap, the physical divide that is very far away halfway around the world. And really, this is the next generation of where these spatial technologies are going, and why I'm very, very bullish on augmented realities and mixed reality technologies. Because as you probably heard recently, Meta, right, Mark Zuckerberg also came out with their new augmented reality glasses, or really, this is the first step, displays. And this is where, again, these technologies and also working with NVIDIA is in the real world, it's not just for fun, but it's also can teleoperate robots to actually understand. So I'm working with NVIDIA on this, and they're saying that when they actually put on the Vision Pros and control a robot, they feel as if the robot's hands are their hands because it's the latency is almost non-existent. And this is really the power of where these technologies are going. And of course, in Omniverse, you can train robots, you can do all sorts of simulations, you can give it all sorts of obstacles to understand how to walk past it or move past it. But the next generation is really, well, how do we train these robots to do household chores, to help us make some food or get our laundry done? And this is where you're starting to actually teleoperate to actually train it. And of course, then in Omniverse and Cosmos, you can completely change the environment. And that's the power of simulation in Omniverse. And this is why I love working with NVIDIA, is because this is really the next generation of how do we actually digitize physical spaces, whether it's brownfield or if it's a brand new terminal for Changi Airport. And what's even more powerful is that, sure, you can actually start controlling robots, but how do you actually make it better to help us with our daily lives? And that's really where things are headed, because every single day, right, we're starting to see physical AI come on. And physical AI is all trained. All of these robots are starting to be trained in Omniverse. And of course, a lot of the other modules, right, whether it's Metropolis or Root or whatnot, it's all coming together. And this is the power of these technologies. And when we think about sort of the future, I showed this 5 years ago, where it said basically back then, in 5 to 10 years, we'll have augmented reality glasses. But of course, today it's already here, right? Apple will continue advancing their Vision Pro, and maybe they'll come up with a Vision Air, just like the recent iPhone Air. It's very thin. They're waiting to basically put this, slap it on our faces. And of course, with the new, the Meta Ray-Ban display, it's the first step. And this is amazing because, sure, it's just augmenting some data, right? It has maps, it can navigate, but it has not become a mixed reality experience just yet. It's getting there. So I would say another couple years, you're going to get the next generation of this. It'll be more affordable, right? This is still what, $800 US. And the power of this is that the neural wristband, how do you interact with the data? Do you constantly just talk to AI? Do you say, hey, Meta, do this or that? How do I write? How do I, message back on WhatsApp? Well, this is the thing where a lot of new innovations are coming. How do you interact with that data? How do you actually respond? What if you're in a crowded environment? Do you keep talking to AI, or is there a better way to interact with it? So this is where the future of these spatial technologies really headed towards, right? Because whether it's walking outside to navigate, to capture Pokemons, or whether it's doing work, right, to actually increase the efficiency of what you or your colleagues are doing, this is where the information, and what I said earlier is that these days we can access the entire internet on the palm of our hands. But the next generations really, we want this data to enhance our lives, but also enhance our work, to actually give us more data. Of course, again, you have to opt into this, right? Whether it's spatial advertising or something else. But again, we want to access the data faster and much more seamless in our lives so that we can actually free up our hands. So a lot of the technologies that change the world, right? This is why right now I'm actually on a standing desk, because I've been involved with technology way too long that I have a lot of pains all over, right? My neck and my wrist and everything. But this is why spatial computing is so powerful, and why what we're doing with spatial digital twins is to have that digital infrastructure for their world, right? Whether it's airports, water treatment sites, and whatnot. We're starting to work with hospitals as well. So once actually doctors can understand the digital information of, let's say, that patient, but then immediately they can say, hey, where's the ultrasound machine? And it'll actually tell you it's about 500 meters over there in the next room. Then they can dispatch and get that over, because every second matters, especially in healthcare. So of course, the future, where is it leading to? There's a lot of contact lens manufacturers these days working on how do we actually access this data, not only just sitting in our faces, but as a contact lens, and how do we actually charge it or keep it charged? So I think in the next 10 to 20 years, we're going to be seeing a lot of that. And of course, if you watch Netflix's Black Mirror, you probably think about, wow, this is very dystopian, sort of like how what we're doing in Shanghai. But again, technology like this can be used for good as well, right? To save lives. And that's really the key thing of what TwinMatrix is really focused on. We want to empower people with superhuman capabilities and to understand the spatial awareness of certain things and to prevent accidents and collisions, for example, at the airport from happening. So this is where and why I've started building these startups, just like TwinMatrix, to focus on. And as we're starting to scale worldwide, I'm very excited to actually form an MOU collaboration with the university, because we see that this is going to be truly next generation, and we need all the help we can get, right? Whether it's partnerships with AWS, NVIDIA, universities, right? Not a single company can do it themselves. And this is why the real world application use cases is really critical. So again, thank you so much. I just wanted to, here's my LinkedIn in case you want to connect with me. And please, here's the feedback form for any questions and comments. Thank you.
Awesome. Awesome. Thanks. Thank you so much, Eric. Great talk. Interesting topic. I think, as I mentioned in the beginning, the future is today. The
It's
future
today.
that you used to see is happening now. So
Yes.
we need to start to wonder what the future will look like in the future. Just like in 10 years, 20 years. So
Exactly.
we do really appreciate your support with this talk during the AI Week 2025. We hope to having you next year as part of the initiative again, and of course we will be in touch. We are connected already, so thank you so much.
Oh, thank you so much, Juan. Thank you, everybody, for joining today. It was a pleasure to present, and hopefully this gave you some new insights and to inspire you to actually build more, because we need everybody to understand where this is headed so that we can prepare for it and benefit the world.
Perfect, for sure. Thank you so much, and thank you
Thank
to all
you.
the attendees for being here tonight.
Perfect. Take care, everyone. Looking forward to working with you.
Of course. Bye-bye. Take care. Thank you.
Bye-bye.